Alright, this is Dr. Corey Glenn, and I'm going to be doing a video taking you through the beta soft version of the Denture software. And so this is just the newest version of Blue Sky Plan. If you're watching this, depending on how far in the future you're watching this, today's date is March 19th. And so this is the very first public release, and it's just purely in its beta form. Plenty of bugs still to work out, but it's at least in a form that is workable and that we can go ahead and release and let people begin learning and begin playing with. So keep that in mind as you're watching this video. I'll show you a few of the issues that are coming up. So this is just a basic version of Blue Sky Plan, and as you can see up here, we're going to have multiple modules within Blue Sky Plan. Currently we're in the surgical guide normal mode, and so let's begin a case. And the way I'm going to do that is that I'm going to simply grab a couple of models out of this folder, which I've entitled Blue Sky Demos. So I'm going to bring in the one that says upper impression, lower impression, and I'm also going to bring in a scan of some bite rims. So I can simply control select all of those and drag them into the case. Now, as you can see, this has pulled the three models into the case here. So first thing I'm going to do is just change their colors just so there's a little color distinction between them. So let's go with a green and a pink and finally a blue. This just makes it easier to reference them really quickly when you're looking for the models rather than having them all be one color. So a few things you're going to notice here right off the bat. We have a bite rim scan, and so this is the patient's denture. I'll take you through his actual clinical stuff here in just a moment. If we hide the visibility on that, you can see the edentulous models underneath this. So let me real quick switch into a PowerPoint and show you how these were generated. So here's the patient. He came in, he had a very old existing upper denture. He had lost the lower denture. And so what was done was that the upper was used as a bite rim. Essentially, we did a reline impression inside of that. And then the lower, a custom impression tray was made. It was used to do an impression. And so as you can see here, that's being done in the mouth, and this is the resulting impression. And then as you notice, what I oftentimes would do back when I was doing dentures is after doing the initial impression, I would cut the handle off and just immediately turn this into a chairside bite rim. So you'll never have a better fitting bite rim than what you're going to have with this PVS intraorally relined impression. And so if you immediately turn this into a bite rim, this could be the very first time you see them using some custom trays, or I'm sorry, some stock trays that can be customized, like the Joe Masad trays available from Nobilium. You can use these and cut the handle off after the impression and then add wax and simply use them as a bite rim. So we've done that on the lower. Here is the upper with a reline impression taken inside of that. And then I'll take a barred Parker, I'll cut back this excess impression material. And in the case of this patient, I didn't really work on trying to nail occlusal planes or anything. I essentially added wax to the lower to get a mush bite, and so I just had him bite down until he was in the right vertical dimension, and this is the final bite record. So this is all the information that we need, along with some pictures. If you jump back to here, you can see this patient's existing dentition. If you were to look at his lip at rest, he essentially didn't show any of his upper teeth, and so in my mind we needed to add a couple of millimeters of length to the incisors. And so that's where we're at in this case. So the very first time you see this patient, you could go ahead and have all the records that you need to make the denture. Now we need to look at digitizing that information. And so there's many ways that you could do this. I'm going to just show you what I use. I have the Shining 3D DSEX scanner, which we sell at Blue Sky Bio. This works really well. You can orient impressions and bite rims and all of those things onto the scanning plate and digitize those. And so this is the way I do that. I create a little pedestal of triad gel material, and I just orient that into the base, because really what I'm wanting to capture mainly is the entire interior of this impression so that I get accurate soft tissue contours, and then I just need this exterior surface enough to see the teeth so that I can orient myself to where was his existing incisal edge, and be able to use that to articulate the buccal bite that you'll also take of these. So in the Shining 3D software, what it would do is you could tell it you're scanning impressions, and then you could say that your occlusion type is registered jaws. So we would first put these models in, just rubber band them together, let the software scan them, and it will take a buccal bite, and then it will have you scan each impression individually. So upper impression and then lower impression. The Shining 3D software is going to stitch those together, and it's going to orient them into the proper occlusion. So that is how we ended up with these three models. Again, many ways that you could get to this point, but that's just what we did in this case. So now that we've got articulated digital models into the software, we need to go ahead and switch from surgical guide module into the denture module. And now we're in the denture module, and so we need to go ahead and import some teeth. So come up here to the plus tooth button. We're going to click on this, and right now there's going to be limited libraries available. Now this is going to be growing quite a bit in the very near future. We're going to have more of the actual denture tooth libraries from Nobilium, in addition to some custom libraries like the Christian Brennis library, like the Mitch Hurst library, and I've got several other really nice custom libraries coming from a number of technicians. But these are the three options that we have right now. This would be your T5 anteriors, your T7 anteriors, and your T11 anteriors. And those end up working out with the corresponding lower molds and posterior molds. Now, one little nuance to make you aware of right now, I did a mix-up in setting of these T7 teeth, and so if you use those, I'll hopefully have this straightened out on the very next release, but one of the posterior quadrants of, I believe it's the upper teeth, I mixed up and I put in the wrong mold. So I would suggest holding off on using the T7 mold until the next update. For right now, stick with the T5 if it's going to be a relatively small arch, or the T11 if it's going to be a relatively large arch. So this was a large male. Let's go with the T11 mold. And this is going to be using physical real denture teeth. These are the Nobilium Nobildent teeth. So what I want to do here is I could select just the maxillary, just the mandibular, but I'm going to select all of the teeth, and we're going to tell the software to add them as a chain. Now once I do that, you see that I have the teeth right here. So if I push shift on the keyboard, I can now click on the upper model, and I just click in the area of the midline and drop those in, and it will drop the entire upper and lower arches of teeth and drop them in as a chain in occlusion already. Now right now it defaults to being able to manipulate all of these models individually, so I could move teeth. What I want to do initially is move the entire tooth chain, and so when I do this, I can now make big macro movements and begin aligning these within the two arches in the proper alignment. So we'll pull these over. These are all of the same widgets that if you're using Blue Sky Plan already, that you should be accustomed to. We've got the arrows to drag things right and left, up and down, to bodily move them, and then you have all of the rotation rings to grab them and drag them in their respective planes. So in this case, we did use a buccal bite on this, and so we can use that to help us reference where to locate these teeth. So let me go up and turn on the buccal bite. Here are those bite rims. Now, as far as how far out the teeth were sticking anteriorly, I liked that, and so let's pull these back until they are basically in line with the position right in that neighborhood. The midline was fairly close. It could stand to go just a tiny bit to the right, which it looks like we've achieved here. And then the occlusal plane I did not trust whatsoever on this particular patient. It was somewhat of a roller coaster with that existing upper, and so I'm going to orient that more just by eyeballing it. So, you've got numerous anatomic landmarks that you could use. You could say your occlusal plane wants to go from incisal edge to 2/3 up the retromolar pad. And so if we're doing that, we might want to put it about right there. And that would give us a proper occlusal plane. And that looks about right, as looks like what you would expect in between these two edentulous arches. So let's go ahead and go with that. I'm going to come back to the denture tooth panel. If you needed to visualize these panels, just like in the surgical guide mode, you can come up here to panels and turn on the denture design panel as well as the tooth surfaces panel. So deactivate the red button here for move the entire tooth chain, and now these teeth are back in to their locked position. Now back to manipulate model. If I clicked on this, I'm just going to show you some of the functionality. This allows us to manipulate any model within the case. So, if I wanted to do that, I could rotate that. Let's click back because obviously I don't want to move the models. Those are set in the proper orientation. So if you check this box, it will lock the models and it will only now give you the ability to hover over teeth and move those individually. So if you wanted to make individual tooth movements, this is how you would do it. So let's say you didn't like how far anterior those were and you're willing to sacrifice occlusion to reduce the amount of overjet. Well, that's where I could now begin moving these teeth. Now, this is going to add substantially to the time required on setting this, because now you're going to have to line everything back up and get them in the proper relative position to one another. The big goal in doing this was that we can hopefully just bring the teeth in already occluded and just make large macro movements. So rather than doing that, let's go to show and hide the tooth chain. Now when we activate the tooth chain, this is what you'll see. The teeth all get chained together. They're all approximately 0.1 millimeters apart in width and spacing. And this chain now can be locked in various positions and teeth moved while not screwing up their position relative to one another. Now we've got a few options here. We can hide the mandible teeth chain and just show the maxilla. I'm going to leave that showing right now. We have this button right now called Keep Opposing Arch and Occlusion. This function is not working properly yet, so just be aware of that. What this should do is keep the teeth, for lack of a better term, magnetized to one another, so that as we make movements, it still wants to maintain occlusion to one another without the teeth impinging into one another. However, that is still a little buggy right now. You can play with it if you want, but do realize that's a bit buggy. But what is working is this move opposing tooth, and so for example, let's lock this molar, and if I was to push now shift, you're going to have to push shift to make movements, and now left click and bring this tooth down. You can see the response of the opposing tooth to that. It moves the opposing out of the way, and it does not allow collisions that are going to impinge on one another. So let's undo that. And so the big goal here is that we would just be making large macro movements rather than individually having to position teeth. So let's say that we wanted to put in a bit of a curve of spee. You could perhaps lock the lower canine and shift, grab this second molar and pull this up a little bit. And as you can see, a little bit buggy. If you ever do that, just hit the back arrow. Let's instead lock the canine and go up here. There we go. That's a lot better. Okay, so you can see there's a little bit of trial and error. I'm still playing with this and figuring out some of the functionality nuances. But as you can see, that maintained occlusion pretty well. So we could increase the curve of spee there. We could do the same thing on the other side. So we can make these movements. We could also look from, let's say, the occlusal. We could move the arches in and out. So if maybe we wanted to hover more directly over the ridge, we can do that. So this is a really, really useful function, and it's going to allow you to set these teeth very, very rapidly. Okay, so let's assume for sake of this demo that we're going to go with this position, and we are ready now to make the denture. So go back to your denture panel, and we're going to tell this that we are going to, let's first turn back on the upper model, and I'm going to hide the lower model for right now. Let's say that we're going to build on the upper model our maxillary denture, and now we can push create denture. So let's restart the case. I had done a previous case on this. So the first thing that's going to pop up is this rotation ring. This is your axis of insertion. So anything that's dark brown that you see right here, that's telling us that that's an undercut, and obviously so, because the direction of insertion is coming from back here. As I pull this and bring it to more of an anteriorly positioned axis of insertion like you would have coming in from the front of the mouth, you're going to see most of that undercut disappear. Still a little bit right here. We can straighten this up. We can modify this as much as you want to minimize undercuts. And now you'll see that you have the option here to allow the undercuts, or to allow them up to such and such amount. Let's say we wanted to allow them up to a very high degree, which I would typically want to do if this is going to be the definitive denture. Let's say that we're printing or milling this base. I would want to maintain as much of those undercuts as possible. Why would you want to not allow undercuts? Well, suppose that rather than doing a printed or a milled base, that your goal is to perhaps print a trial base with undercuts removed, one that would fit back on the maxillary model, and that would allow you to pop these teeth in, to do a wax try-in. Each of the teeth could be popped in with just a drop of wax, and you could try this in, and if all is good, you could now hand this printed base off to your lab, and they could conventionally process this. So this software is so versatile in that it allows you to do printed bases, milled bases, go straight to finish, printed teeth, conventional denture teeth, or it lets you do conventional processing the old school lab way. So I think even the labs are going to find this to be really, really helpful. So let's assume that we're going to allow quite a bit of undercut here, and this is going to be the axis of insertion. So now I could define the posterior palatal seal. Now you see here that I've already got a posterior palate seal in this. Here is another function that right now is buggy. What you would do if you were going to use this is you would push shift, drop a point here, and drop a point here. But do you see the obvious problem with this? It's there's a little bug that's causing it to go in backwards, and but I'll show you the functionalities that you're going to have with this. So you could change the shape of the Cupid's bow. You could make it deeper or shallower. You could extend the length and width, and you can also mess with the thickness of this. But right now that's not a very functional tool, simply because it's oriented the wrong way. Very simple fix. We'll have that fixed in the next update. So for right now, let's clear the posterior palatal seal, and let me jump out and show you how I created this, so that you can know how to do that in the meantime. So jump over to Mesh Mixer for a moment, and let's suppose that you just used your scanner or whatever to generate a model of the maxilla. Okay, so you've got this. Let's make the posterior palatal seal in this model right now. Super, super easy to do. Use your select tool. Go down to a smaller brush size. That's about perfect. And I'm just going to draw now the outline of the posterior palatal seal. And then I could come and also draw the Cupid's bow. Alright, so we have that. Now come to modify, and let's smooth the boundary of that. That's just going to take away some of the jagged edges of this boundary. Much smoother now. And you can click extrude. And how thick do you want that posterior palatal seal to be? Let's say we want it to be -1 millimeters deep. And as I do that, you see how it sunk that down by 1 millimeter. Make it however deep you want it. And once you do that, the only downside to this is you're going to have somewhat of sharp edges because it's just a straight down extrusion. So to fix that, come over to your sculpt tool, use your brushes, and go to robust smooth. And I'm going to bump up the size of this tool a little bit and just run this thing across the sharp edge. Okay. And as you can see, that is going to smooth this out and basically give you the equivalent of what you would have if you were to scratch this into a stone model. It's going to be a nice, accurate posterior palatal seal. As you can see, it did not take much time whatsoever. And once again, just smoothing that out, making sure there's nothing jagged. Beautiful. Okay, so now we have a model that's ready, and you could now go to File, Export Data, save this into whatever folder, and now that would be the model that you would import as the model to build your denture on. That's how I got this model. So just a quick hack that you might have to put up with until we fix this with the next update. So for the moment, we're not going to do a posterior palatal seal because we've built one in. I'm going to click Next. Okay, so the software thinks for a minute and then it blocks out those undercuts as is necessary. You can see it really did not block out a whole lot because we told it to allow those undercuts. So even though we had some areas that were dark brown here, you can see that it has not blocked those out. So the next step it's saying is to select the denture base. This is where you define what the borders of your denture are going to be. And this is much like drawing the perimeter of a guide. You'll push Shift and left click to drop a point, and then rather than drawing a line, you're going to just simply click your way around the arch and drop points. And then if you need to, you can grab any of those individual points, push Shift, and you can drag them into position, modify that. So, spend a little time making sure you like your borders of where this perimeter is. And once you've done that, you can click Next. Now you'll see a couple of buttons here. One is for the thickness of the denture, and so that's going to default to 3 millimeters, which I think is probably appropriate. The other is the offset. Now the offset is how far off the gingiva are you going to do this. So let's say that you're going to make this your definitive printed base, and this is going to be what you actually deliver in the patient's mouth. Well, then you don't want to create any offset. You want to minimize that to 0. That way you're not going to have any slop space between the arch and the denture base. If you were doing this as a printed try-in and you were going to do conventional processing, well, now you want to create a little slop space just like you would with the surgical guide, so that this can seat completely down onto the master model and you can not have to worry about binding or anything as it tries to seat on there for processing. So that's what those two numbers are. Once you have those set to what you want, click Next. The software has now created a uniform 3 millimeter base, and so you can see this is much like adapting a piece of pink base plate wax down onto the master model. And the next step is that we need to define for the software, okay, this is just a uniform thickness over the model. Where would we like it to build additional gingival material up into between the teeth? And so basically it's going to bring up a plane like this, and what I like to do is position that plane where it's right at about the contact areas, because that's where I want it to build up additional gingiva. So orient this to where everything lines up. It's following right at about the level of the contacts, and it's even from right to left side. And once you've done that, you can click Next. And the next part is where it's going to ask you, okay, you want to build gingiva up to this point. Where do you want to build it from? Do you want to build it from all the way down here in the palate? And so what you're typically going to do is define an area, approximately around the perimeter of the teeth. It really depends on how deep you want this to build up from. Maybe you want it to come from all the way near the border. But in my case, I'm going to want to make it more or less follow just in excess of the width of the arch of teeth. If you ever want to add a point, if you can just come back to your line and push Shift and click again, it will add one more point to it. So that's where I want it to build the gingiva up. So as we do this, watch, let's find a good area for you to look at. Let's watch right here. in that area where you've got a lot of gingiva missing, and hopefully you'll see that this will build up additional gingival material. And now you see that this has filled in more of the space between the teeth. Now I like to have a little bit of excess as opposed to too little, depending on the case, honestly. If I wanted to add a bunch of gingival composite for custom festooning and things, I would leave that short. But if I'm just going to go with the definitive printed base, I would rather add too much because it's a bit easier, in my opinion, to take away than it is to add. So now we're in step 5 of 6, and this is where we have the opportunity to do digital festooning. So this is where you can get creative and really add to the character and the overall appearance of the denture by doing the festooning. So several tools here. You have add and remove, smooth, relax. You have local deform. This is the tool that I use most often. And so you'll still notice that there are areas that are deficient like this. Okay, so that would be an area of the base, or I'm sorry, of the tooth where the neck really wouldn't have much acrylic around it. And so I could come in now and use these local deform tools. Now, if I hover on this and use my scroll, I'm pushing shift as I hover, and I'm pushing the scroll ball forward, it will grow or make smaller the size of my spot depending on which way I roll that. And now if I look from the side here, I can push shift again, and as I'm holding it, now I can left click and pull out some more gingival material. Okay, so I'm adding thickness to the gingival material to help cover the necks of that tooth more. I can do the same thing here. And so this is where you just need to play with these tools and get used to how they behave, to know how much exactly to drag out, what size spot tool should you use. This is clearly over contoured here, and so I would want to bring this back a little bit. We can come in and make really large movements to cover up more of the back side of those anterior teeth. And this tool, it should be noted that as you get over here towards the edge, you're not going to have to worry about messing up the interior of the denture. We've made it such that the tools will not affect the interior surface, so you know, that's a good thing because you don't want to mess up the internal fit by dragging the gingiva away from that. Obviously very deficient here, so this would be a case where I would use a very large spot size, and if I wasn't careful and if it was to bleed over the edge here, it would alter the underside. But as I said, that won't happen. You don't have to worry about that. So I can grow the gingiva out here. I'm stretching it, pulling it up around the necks. I can minimize the spot size and pull it back a little bit if necessary. And then you've also got smooth tools, okay? So you can do the same thing. Your spot size can be varied. You can now hold down the shift key and left click and smooth over this surface. Now I don't put a lot of effort into smoothing things on the borders like this because in my opinion that's easier done after it's been printed, to just take a handpiece and a polishing burr to that and make quick work of it. So I think you'll find in all these workflows, there's some things that are just simply easier to do with a lab handpiece. You know, I like sometimes to add gingival character by using things like annex gum or gingival composites or acrylics, things like that. And so sometimes it might be worthwhile to actually pull the gingiva back, almost like a cut back, and that leaves you space to now do your characterization with those gingival materials. You've also got your add and remove tools, and so this would be useful in some of these areas where the embrasures are a little overfilled. So let's look right here. I'm going to push Control and Shift and scroll back, and that will reduce my spot size. Now for your add and remove, if you use the Shift key, you'll see that it now, Let's bring the strength up. There we go. If I push shift, you can see that it works like an inflate tool. If I push control, you're going to see that it takes away material. Okay, so as I push control, I am scaling back this gingival material in between these papillae, and we can shape this up however you like. So again, this is where you can spend the most time in this process, and it's also what will make the most difference in the overall appearance. You can make things look really nice by coming in with your add and remove tool and making a gingival call. So if you use a spot size approximately like that, I can push shift now, and I can come around just the neck of the tooth and make a slight bulge right along that gingival margin to make that look more realistic. And I will tell you that when you're making these movements, they look enormous on the screen because you've got things blown up so much. You'll be amazed at once you print these how little they show up. So if you're trying to do characterization like this, I would tell you to over exaggerate it, because I think you'll be a lot happier with the end result. And so you could come in and really, exaggerate these right around the necks. And I think you could even do more than what you're seeing right there. Actually, you could do quite a bit more. You could add root prominences. Okay, so maybe you come with your add tool and you make areas over the root prominences that are going to look more natural. Again, that could also be done by just leaving this deficient and doing it with PMMA by salt and peppering it on, or using a gingival composite. So get as fancy as you want on this for the sake of the video. I'm not going to spend much time on this. And once you're ready, you can click the next button. And this is where you can finalize the case. And so your tooth offset, this is going to be the amount of space that's left. So the software is going to, in areas where the teeth are impinging through here, it's going to cut these teeth back and maintain a certain thickness of the base. And so that number right now is set at 0.1. I think that's appropriate. I would leave that as is. The denture thickness. The other important thing here is your denture tooth reduction coping. So as you can see, I've got numerous teeth here that are impinging into the model. How do I know exactly where to adjust these teeth other than to just keep the screen up and look at this and then eyeball it on the physical teeth? Well, we can create what's called a denture reduction coping, and that's going to enable us to create a separate piece of acrylic that you can pop the teeth into, and it will allow the teeth to impinge through so that you can quickly and efficiently adjust those and get rid of any of those excess areas. That way they will pop into the final base. So we do want to create a reduction coping, and now let's click Finalize. Okay, so here is the final result. Now that last step, I will have sped it up on this video, but that takes a couple of minutes. Great time to go do a hygiene check to just let that thing work, because there's a lot of surfaces that have to get created in this. The software is having to do numerous Boolean operations, subtract things away from the base, trim the teeth. So give that a little time, be patient with it. But now you can see, if we go to our tooth surfaces panel, we've got a lot of different models here. So let me go first and look in the inside. Do you notice now that there are no teeth impinging up into the inside of this? And you also see this modeled appearance of the denture tooth base and the model. That's because, remember, we reduced the offset between those two down to 0. So if I right click on this model, I can toggle on and off the visibility here. Here is the interior of the denture base. As you can see, there's a nice posterior palatal seal simply because it builds down into the one which I created. All the undercuts have been maintained, so this will be a very, very nice fitting base. And you're going to see in your objects browser that there are two sets of teeth. So we have, if I hide a few of these, you're going to see that there are subtractions now made for the teeth. And do you remember how the teeth were impinging? Actually, I'm not sure that any of those teeth were. I'll show you on some of the others. But right here, these teeth were not impinging anywhere, so you can see that there's a complete socket created for these particular denture teeth. Now again, these are nobilium, noble dent teeth. These are really an excellent tooth for this purpose because, as you can see, they've got some built-in diatorics and retention built into them. And so these things tend to bond in very, very well and have lots of mechanical retention when you bond them in. So a couple of sets of teeth, you're going to have the ones that are just the conventional teeth, and then as we get down here, these are going to be the reduced teeth. So they'll be annotated by a small R beside them. That tells you that it has been reduced, meaning that there is some tooth reduction that's been done on that. So let's hide this tooth. Now, right here, that was an area of impingement where this tooth was impinging into the underlying model. And as you can see, what the software did is it did a reduction on the tooth. It maintained that 0.1 millimeter of thickness to the denture base, and we're going to have to trim the tooth appropriately to match that. We could do that now with all of these teeth. Let's go back up and turn on the right second molars. So again, do you see how those would have been impinging? If I turn on the original teeth, which have not been trimmed, you can see that they go all the way through that. Now let's look at the denture base materials that we've got. There is the denture base final, and then there's the reduction coping. So the reduction coping is nothing more than it's basically the equivalent of what you would get back from your lab. So let's say you sent a crown off and they say, hey doc, you've under-reduced, and you say, well, I want you to finish the case. What they're going to send you is a tooth reduction coping, which you would drop on that crown prep, and it would tell you, hey, anything sticking up beyond this is where you need to adjust so that this crown I made will fit. This is the exact same thing. This is going to be something that will get printed in addition to your final denture base, and this one actually allows the teeth to protrude through. And so what you would do is now pop the teeth through. Anywhere that they're protruding through this, you're going to take a lab handpiece and you're just going to simply wipe that out. And once you've wiped that out, that is going to enable this to fit into this base. Okay, this is the one, let's turn off those teeth. This is the one where the denture software knew that you didn't want any perforations into the interior, so it will adjust those denture teeth in the areas like you see right here. So it's critical that you be able to efficiently and quickly adjust the actual denture teeth so that they fit in here without having to guesstimate and hope that they're seated. So that's the way that gets accomplished. Right now, it doesn't exactly create a path of draw, so I think you'll find, particularly on canines, that you'll oftentimes, to be able to pop this tooth in, you might have to take a handpiece and also adjust a bit of that undercut away. The canine is where that's going to be most pronounced, so if you have difficulty pushing that in, just take a handpiece and adjust that a little bit. You're going to be adding bonding material to bond that back in anyway. So these are all the files that it's going to output, and you would now go and use the physical T11 mold. And so these teeth, remember, if you look back here, the name up here tells you exactly what you're using. This is the T11 upper anteriors, the L7 lower anteriors, 34U upper posteriors, and 34L lower posteriors. Those would be the teeth that you would order from Blue Sky Bio, the noble dent teeth, which Blue Sky will carry. And so that would be what corresponds to popping into these sockets that have been created. So let's go back now and look at how to finalize this case. So you've got all these files. Now you can 3D print or mill the actual denture base. Remember all those areas of impingement. This is assuming we did the lower two. Those thin areas where you can see daylight through it, that is the areas where the tooth reduction has been accomplished. So up here in the front, you can see no tooth reduction was done, and we've got a nice thick base. Back here in the posterior, lots of tooth reduction got done, and that means that we're going to have to use that denture tooth reduction coping to properly adjust these. And this is what that reduction coping would look like. Here I've printed it in gray, and it's just going to allow parts of the teeth to protrude through. So anything I see here protruding through, I use a pretty aggressive burr made by Parkel called their Hedgehog burr, and it makes quick work of this. It also leaves a really rough surface because of all the spikes on the burr, and that's good, I think, for the retention of these teeth. And so now you would bond in those teeth. So you've adjusted those with the tooth reduction coping. You're ready to now bond these in. So you would prime these surfaces, you would prime the tooth, and then what I use is actually there's numerous things you could use, but I just use the actual 3D printing resin. So you've got your pink resin. I just take some of that wet and I wet the interior of this, leave it a little, a few drops of it in there, and then take my tooth. If you wanted to cut additional retention or poke holes in the underside of the tooth with a burr, you can do that. And I'll do that and then brush the tooth and the inside of this and then press the tooth in. There'll be a nice definitive fit, and then you can wipe away any excess with a brush and then hit that with a curing light. And so your composite curing light will work great for this process, and then you can stick this into a curing unit to do the final cure once everything else is done. You can also see the difference here between how it's going to look straight out of the printer, where it's going to have these layer lines between it, and what it will look like if you paint over it with a very thin layer of that uncured printing resin. So I don't polish these with pumice because you would spend a lot of time getting rid of those printing lines with pumice or with burrs. I actually just use some additional resin. And so paint that on, get it nice and smooth. I like to hit it with a hair dryer too, because the warm air will burst any bubbles that you may develop with your paintbrush as you're brushing that on, and it smooths things out with the heat, gets it nice and glossy. And then once again, hit it with your composite curing light, and then once you've done this, the teeth are tacked into position, stick it into your UV curing oven and let this get its final cure. And these were the teeth that were used for the case. So again, Nobilium Noble Dent teeth. This was the final dentures, upper and lower, for this, and they look really, really nice. These look on par with really anything I can get from the lab. And for delivery, you know, it's inevitable, just like with conventional processing, the teeth can move ever so slightly. There's about a 0.2, 0.3 millimeter offset or slop space between the tooth and the socket. And so, you know, you've got that much wiggle room that you might over or under seat the teeth when you're processing these in. So you got to check occlusion, that's inevitable. You could either do a digital remount, or you can, what I like to do is in the patient's mouth, use occlusal indicator wax from Kerr, and this allows them to bite into that softened wax and really see the prematurities, but it keeps the tissue pressure even and keeps them from just, you know, bouncing and sliding off of a prematurity. So I can look at this and see that's a prematurity, that's a prematurity, this and that are prematurities. This is not quite. You can see it's not all the way through. That tiny little bit is. And you can just adjust right through this. It really makes adjusting your dentures much more precise. And this was the final result for that patient. And so the lighting's not the best in this picture, but compared to where he started from, this is a big, big improvement. So we went from this, and this was the second time that I saw this patient. I keep saying me, I worked with my associate on this case, but I did the lab work for this. But this is the second time that we saw this patient after getting those master impressions. And while we didn't deliver them the next day, they were actually completed and ready to deliver the very next day. And so I think this is going to be a big game changer as far as making dentures much more efficient. And we will most certainly be improving this software dramatically in future builds. So do keep in mind, depending on the date that you're watching this, some of this may be out of date and irrelevant as we fix some of these bugs and add new functionality. So let us know what you think, and we are open to all suggestions on this, and we appreciate you using it.